Hey guys, welcome back. So this is going to be Virtual Lab 2. We'll walk you through this. Hopefully this won't take quite as long as the first one did. So we'll walk you through this second one. I'm going to go ahead and share my screen again. Get this out of our way. And I'm going to take you back to our assignment list so that we can get into Virtual Lab 2. So again, closing exam 1, closing exam 2, and 3. We'll go into Virtual Lab. This one I've already done, so you can see this. And if I wanted to go back into it just to look at it, I can do that. So I can click back in here to see that study mode. So I can absolutely do that. And I can retake it if I wanted to get a higher score. That's something I can do at any time. Virtual Lab 2, this is our graduated cylinder lab. So I'm going to go ahead and start this. Again, same information. I have unlimited attempts. It's due on the 22nd. I have 20% daily penalty. Final date, due date is 24th. So let's go ahead and start this. So now we're going to be learning to use a graduated cylinder. Again, key concepts. International System of Units, yada, yada. I'm not going to read all of this to you. What we're going to be talking about is learning how to use this meniscus and how to read this graduated cylinder and how exactly we're going to be doing that. So we're going to go into this, and where we need to orient our eye level to take an accurate reading of the meniscus. Okay, and what we need is to know that it needs to be exactly parallel to the meniscus. So we need to be looking at it exactly parallel. If we're slightly below it, then it's not going to be an accurate number. If we're slightly above it, then it's not going to be an accurate number. It needs to be exactly parallel to it. So we need to be holding that thing right in front of us. Okay. So it needs to be exactly parallel. Okay. Cool. Answer the question. Go us. So zoom in on the graduated cylinder. Using my arrow, I need to adjust my eye so that I can read this appropriately. Now, notice that this is not appropriate because I can't see where that thing is. Here, what I can see is that this line right here is what I'm looking at. If I go like this, it's too high. This is exactly even. This is too low. Okay, so this is what I'm looking at. It's this line right here, this one that dips, and not this flat one that I want to look at. Okay, so it has to be the one that has the dip in it. And it's that dip that you want to be looking at. That's where you want to be looking, is that one right there. So the water level that we want to be recording is where this bottom hits that line. Okay, now it may not be exactly on the line, but this one is. So this is 30. So 25, 26, 27, 28, 29, and it's exactly at 30. Okay, so when I record my lab data, what I'm going to see is that volume in the graduated cylinder in milliliters is 30.0. And I have to go one decimal place beyond what I can actually see. So I can see that it's 30. That's what it's measured to. But I can estimate beyond that. And I know that it's beyond 30. So I know it's exactly 30 because I can see that it's exactly 30. It's not slightly above that. So that's why I say 30.0. And you say, all right, 30.0, it didn't freak out on me. So I do that and I say, all right, let's go to the next one. Cool. Now we're going to zoom in here, and while counting drops, we're going to add drops of water up to the 1 milliliter mark on the graduated cylinder. Now, what I'm going to do is I'm going to add, and notice it's counting for me. So I'm going to add and add until that dip line gets to exactly 1 right there. And it did. And I see that it's 25 drops. So I need to put in my lab data that that's 20, it's at 1.00. And that's 25 drops. And so I take my calculator, and I'm just going to pull up the calculator right here. 1.00. 0, 0. I divide that by 25. And that's equal to 0.04. Now, looking at what I'm looking at here, I know that it's 1, and I know that it's point something. So I can see that it's not 1.1. It's not 0.9. Okay, so I know it's 1.0. And I can see that it's exactly 1.0. So that's why I measured it as 1.00. It's 25 drops, so I divide that, and I get 0.04. But since I measured this to 3 decimal places here, that number that I recorded should be 3 decimal places. So if I'm not mistaken, it should be like that. Now, it may freak out about that. Right? And notice that this says how to read a graduated cylinder. And if I open this, it's going to give me some information right here. So what I tend to do is I look at whatever this information is, and I take a screenshot. Because whatever that says, I don't know what it says, whatever it says, I may need that later. So I come into my virtual lab 2, and I paste that right there. Because that information may be necessary to me. It says water adheres to glass walls of a graduated cylinder, creating a curved appearance termed a meniscus. Average accurate volume measurements are taken with your eye level parallel to and at the bottom of the meniscus. In the above image, the water measurements is at 25. So right there at 25, it's 25.0. How to calculate water volume by water displacement. My initial water volume is 10.80. Water plus the object is 17.60. Water the volume difference is the volume of the object. So the volume of the object is the water plus the object volume minus the initial water volume. So I take that difference, and that's 6.80 milliliters. So that's information that I may need later. Okay, so that's what I do with that. Whatever it says, I take a picture of that, and I may need it later. Okay, so anything I have here. And then I have all of the data that I will collect. I will take a picture of it as well. Okay. So I've done this part. So calculated my average, and I go to the next part. Now, I go ahead and zoom in here. And it says measure water volume in graduated cylinder record. So 20, 21, this looks like 22.0 to me. I'm going to put this as 22.0. And now I'm going to move this out. And I'm going to calculate, place the object in there. So I'm going to zoom out. I want to put in the metal nut first. Put that in there. And then I want to zoom in again. And what I see is that it's down to 21, 22, 23, 24. It's not all the way up to 25. So I'd say 24.8, 24.9. I'm going to say 24.9. That's what it looks like to me. 24.9. And so the volume of that object is going to be 2.9. It doesn't like that. So maybe it's 8. In which case, this is 8. And it seems to be okay with that. Now it turned red, and that's how I knew it didn't like what I did. So that's why I said, okay, fine. So now I can say, okay, you like that. So let's see if we can go to the next phase. Then I need to zoom out, and then I want to take this one out. And so I want to make sure that it's still a 22, which it appears to be. And it's going to make you do this every time, even though it appears to be the same number. Now I'm going to put the dye in there and see what that new volume is. And that looks to be just at 25. Which means that this is 3.0. I'm going to zoom out. I'm going to take the dye out. And that looks like 22. Zoom out and put this marble in there. Zoom in, and now I see 25, 26. And that means that this is 4.0. And zoom out, I'll take this marble out, and then I'll go to the next phase. And it's happy with all those numbers. So I answered my question, I put all my numbers in, I got all that lovely stuff out. I'll do a print again. F2. Come back into this. And that's there. So that's information. And again, I may need when I do that post lab. So now I've got that. Okay. So that's the second one. Cool. Awesome. So I am done with this one. I'm going to go ahead and stop here, and I will be back with you shortly.